Wait, what happened? All right, so how's everyone doing? So we got, I just a couple hours ago, I posted taking finding the area using the limit process, limit of the Riemann sum. So I'm not going to make you do that whole thing on a test, but I did it so you see it on the how it's done. So anything you want to ask about before we continue on? We're going to do section 5.3 today, and then later in the evening I will, if not tonight, by tomorrow for sure, I'll post a review sheet for you. I think I should do it tonight. I'm going to keep the same. I'm going to do the same review sheet. So, yeah, and then Tuesday we'll review, and then Thursday, a week from today, is your third exam, which is on April 29th. So that takes care of through week 13, and then after the exam, we got 3 weeks left. So, anything you want to talk about? All right, you guys haven't looked at anything last 2 days, huh? Madison, you have a guilty look. So some people don't have a guilty look. They have like a poker face. You can't tell anything. All right, here we go. 5.3. I think you'll like this section. The fundamental theorem of calculus. So, just a recap of what I talked about last time, I said that a definition of a definite integral from a to b of f of x, that is equal to the limit of the Riemann sum, limit as n goes to infinity of the summation from I equals 1 to n of f of x sub I times delta x on the interval AB. Then after half an hour, you get your answer. But now with the fundamental theorem of calculus, I'm going to show you how you could calculate the area underneath the curve really quickly. So there's two parts to the fundamental theorem of calculus. I actually like teaching part 2 first because it's easier. I don't know why it's numbered that way. Olivia, can you look up why the fundamental theorem of calculus part 2 is part 1? Never mind. I swear in the book that I taught it when I first time I taught calculus, part 2 on this book was part 1 in the other book, but in this book it's called part 2. So we're going to go part 2. So what that says is if you have the integral from a to b of f of x dx, the answer to that is capital F of b minus capital F of a. And you do that, you can get, granted if the function is above the x-axis, that will give you the area. So let me show you how that's done. Suppose I want the area from integral 0 to 3 of x squared dx. How do I calculate that? So first, let me explain to you what that is. That's getting the area of a parabola x squared from 0 to 3. So here's 3. If I want to get the area of this shaded region right here, one way to do it is to create those rectangles and get an approximation, take the limit as n goes to infinity, do the whole summation and n and I and all that, and then half an hour later you get your answer. Now we're going to do it quickly, the shortcut. So capital F is the antiderivative of little f. So what's the antiderivative of x to the second? 1/3 x to the third. but you don't put the plus c. This is a definite integral. But you do put a little bar here with a 0 and a 3 to show that the limits are from 0 to 3. You don't want to put the integral symbol on anymore because you took the antiderivative. So the integral, I didn't say this last time, means to take the antiderivative. So once you take the antiderivative, now keep in mind the top number here, 3, that's your b. The bottom number is your a. So what the f of b minus f of a means, you plug in the top number 3 minus plug in the bottom number 0. So we get 1/3 times 20, 3 to the third is 27 times 1/3 is 9 minus 0. So the answer is 9. So that's it. The area of that shaded region is 9. That's it. Now you're wondering, wait a minute, do that for the problem that you did last time, which took you a long time to do. In the end, you got 39/2. So remember last time I said, find the area underneath the curve of y equals 3x minus 4 on the closed interval 2 to 5. And I did the whole limit as n goes to infinity of the summation. So if you want to do it quickly, the area is going to be equal to integral from 2 to 5 of 3x minus 4 dx. So I'll show you how it's done quickly now. Are you ready? Don't blink. So first you take the antiderivative. What's the antiderivative of 3x? 3/2 x squared. Minus antiderivative of 4, 4x. From 2 to 5. So what that means is you're going to plug in 5, which is the top number, minus plug in 2. That's the f of b minus f of a. So we plug in 5. So that whole thing is my f of b minus f of a. So plug in 2. 3/2 times 2 squared minus 4 times 2. All right, and then now you just do some simplifying. So that's 25 times 3 is 75/2 minus 20 minus 4 times 3 is 12/2, which is 6 minus 8. All right, so let's see here. 75/2 minus 20 minus -2, which is ended up being plus 2. So -20 plus 2 is -18. 18 is really 36/2. 75 minus 36 is 39/2. And see, no sigma or no I and n or anything. Just some number crunching. You like this way better, or you prefer the old school way? The old school way? I saw some nodding, Robert. All right, so let's do some more. Now again, this integral, when you do a definite integral, it's only the area, it represents the area if the function is above the x-axis. So if the graph looks like something like this, then it's not the area under the curve because there's parts that are below the x-axis. We'll get to that later. Actually, let me talk about that now. So here's what's happening. Let's do a few more integrals and we'll talk about it. So just evaluate the integral. So right now, use the fundamental theorem of calculus part 2 to evaluate the integral. And don't necessarily worry if it represents the area or not. If the whole thing is above the x-axis, it represents the area. If not, then it's not the area. Just evaluate the integral. The integral from 1 to 8 of the cube root of x. So now, remember you learned how to take the antiderivative in the last chapter. So you take the antiderivative, but you don't put the plus c. But once you take the antiderivative, then after that, you plug in the top number minus plug in the bottom number. That's the f of b minus f of a. So first, let me actually show you some notation that I want you to be familiar with. So I got to rewrite that cube root of x. Now, because I'm rewriting it, I have not taken the antiderivative yet. So since I have not taken the antiderivative yet, I do not take the integral symbol off. You only take the integration symbol off once you take the antiderivative. So go ahead and try to do this. Have you guys seen the movie Willy Wonka and the Chocolate Factory? The original one, like from the whatever it was, 70s or something. Now, when I moved to America as a little kid, imagine a kid watching the movie without speaking English. You're watching elementary school. I thought it was a horror film. These kids are falling to this little chocolate pool and they just get sucked into something and they go and die. I'm like, what is this? Have you seen the recent one with Johnny Depp? I haven't seen that one. Is that good?
I would say Johnny Depp is really funny in it, but it's not as good as the classic.
Okay.
It has its moments.
I
Like,
haven't
it's
seen
very-
the new. I haven't seen the new Total Recall either because they remade Total Recall. It's a different story. But the one in the whatever is 1990 with Arnold. That's the original Total Recall. No, that's a different movie. Get to the chopper.
That's True Lies.
No, oh no, I thought it was the one, not Predator, Commando.
Yeah, it's Predator. I'm pretty sure it's Predator.
I thought it was Commando, where the helicopter comes at the end. Basically, it's the one where he kills everybody. He takes on the whole army. He rescues the little girl. Then once it's all over, then the backup military comes. We're like, he already did all the work. It's one of those like old school action movies where it's like unrealistic because like one guy takes on the whole army. Oh, it is a present. Okay. Add 1/3. 1/3 plus 1 is 4/3. Then divide by 4/3 is the same as multiplying by 3/4 from 1 to 8. So now you plug in 8 minus plug in what? So now you need so just FYI, this is your f of b minus your f of a. So 8 to the 4/3 is actually a nice number. It's cube root of 8. And then to the 4th power, that actually works out nicely. Minus is just going to be 3/4. So cube root of 8 is 2 to the 4th power is 16 times 3 is 48 by 4 is 12. 12 minus 3/4, which is 11 and 1/4, or 11 and 1/4. How many guys left on 25? No, 25 on top has choppers in it. So you know the villain in the guy with long hair. His name is Richard Tyson. The real movie that I saw him in This is old. Just my brother know about this movie. I don't think if I say it, people know. It's called Real Block High. So again, a little kid right watch Real Block High. It's about so Richard character plays this big high school bully. And he doesn't talk. Everyone's afraid of him. So this kid in high school newspaper starts talking to him and wants to interview him and caps him, and then he wants to say, "You and me, 3 o'clock after school, we're going to fight." So keep in mind, you're like 9 years old watching this, freaking out. Like this bully wants to fight after 3 o'clock. So the whole movie is like anticipation of real clock, what's going to happen. So he's trying to get out of the fight. And it's not that great a movie when you're 9 years old. So 3 o'clock high, you're watching. And people find I don't know where you want to watch. It's not on Netflix, has it? You have crap. All right. You guys getting level 1? Okay, very good. Okay, so again, if you know how to anti-derivative, you know how to do these. If you think things like what we're aware of, when you're integrating, you're taking the anti-derivative. So keep in mind, so for example, let me do one more here. Let me show you a move here. Suppose I say integrate from 1 to e of 4 over x dx. You can always factor out a constant from an integral. So I can take the 4 completely out of the integral, but you could only do that with a constant, okay? You can't ever take out an x, but you can take out a constant. Now, what's the antiderivative of 1 over x? ln of x from 1 to e. Now, you could choose, do you want the 4 with the ln or without it? Doesn't matter. You could have the 4 completely factored out, or you could write it with the ln each time. So you plug in the top number e minus plug in the bottom number 1. So ln of e is just 1, so 4 times 1 minus natural log of 1 is just 0. So the answer is just 4. Keep in mind when you're taking the antiderivative, if you're taking the antiderivative of a sum, you can just treat them like separate questions and just take the antiderivative of each part individually. But if it's a product or a quotient, you got to be careful. You might have to do some algebra to rewrite it. So do the best you can on the following, okay? I'm going to give you 3 questions. Do all 3 of them. The integral from, you know what? I'm going to rewrite my this. Okay. So the integral from pi to 2 pi of cosine theta d theta. Do that one. Then when you're done with that one, the integral from 0 to 2 of y minus 1 times 2y plus 1 dy. That's it, just do these 2. All right, no problem, Brian. All right, if you're done with both questions, can you put a done in the chat so I know how many people are done? Thank you. You can private, if you don't want to show off, you can private message. Where is Amon at? Oh, there you are. Okay. Good day. How are we doing?
Still working on it, Professor.
Okay. Aaliyah, do you have any announcements?
No, nothing really.
Mhm.
We're doing good. Thank you.
All right. All right, so let's go ahead and do this here. So the antiderivative of cosine is just sine, because the derivative of sine is cosine, from pi to 2 pi. So you plug in 2 pi, what's the sine of 2 pi minus, why did I put a 2 there? Minus, I have no idea why I'm putting a 2 there. Minus sine of pi. So sine of 2 pi, that's the same as sine of 0, which is 0. Minus sine of pi. What is the sine of pi?
0.
Yeah, okay. Okay. So here's what happened here, by the way. How can the area be 0? So let me explain to you why. I'll get to that question in a second. So let me show you the graph of cosine of theta. So this is pi over 2. All right, so this is the graph of f of x equals cosine of theta, right? Or theta in this case is the x. So so this is -1, and this is 1. I know it's not up to scale here, but so if we're integrating from pi to 2 pi, what happens is we're integrating from here to here. So what happens is if the function is, the whole thing is above the x-axis, then it would represent the area. When it's below the x-axis, you get what's considered quote unquote negative area. So in this case, what happened is the shaded region that's below the x-axis or the theta axis right here is exactly the same area as this area right here. So they canceled each other out, so to speak, and that's why you got 0. But you don't know that unless you see how the graph looks like. So, which brings me to my next point, and I'll still do that next problem in a second. If you have, I got to talk about this here. Let's say you had a curve that looked like this. And let's say the area of this hump was 10 square units, and the area of this hump was 3 square units. And you're integrating from 1 and this is, let's say, 20, and this is 30, as far as the x values go. So let's say this is f of x. If you were to integrate from 1 to 20 of f of x dx in that problem, you would get the answer of 10, which is the area. But if you were to integrate from 20 to 30 of f of x, you would get an answer of -3, because from between 20 and 30, it's below sea level, so to speak. When it's below, the answer is going to be negative. But if you don't know how the graph looks like, and you were to just to integrate from 1 to, let's say, 30 of f of x, you'll get an answer of 7, and you won't know why you got 7. Well, what happens is you got the 10, which is positive area, it's above sea level, below negative, so that's why they cancel each other out, so you get 7. So what happens with this trig graph is that the above area is exactly the same as the below area, even though my picture doesn't make it look like it. So they cancel each other out and you got 0. Does that make sense? Yeah. So when you're doing the problem in the homework, a lot of times they won't even ask you about the area. They'll just say evaluate the integral. So you could get a negative answer, you could get a 0. If you get a negative answer, it means more of the graph is below than above the x-axis. That's all it's saying. But you just evaluate the integral. All right, so let's go back to that other question here that I didn't do yet. So the integral from 0 to 2 of y minus 1 times 2y plus 1 dy. By the way, did any of you still need to copy this down? Birthday, you're good? Good. So let's do this one. First of all, you can't take the antiderivative when it's a product, so you got to multiply it out. So y times 2y is 2y squared plus y minus 2y minus 1. Two y squared minus 1 y minus 1 dy. So let's take the antiderivative. First term, it would be add 1 to the exponent, divide by 3, so you get 2/3. Minus 1/2 y squared minus y from 0 to 2. Any questions so far? Now plug in the top number 2. Minus plugging the bottom number 0, which I can see in my, it's just going to be 0 for all of them. So 8 times 2 is 16 over 3, minus 4 over 2 is 2, minus 2. So you got 16 over 3 minus 4, 16 over 3 minus 12 over 3, which is 4 over 3. Did you guys get 4/3? All right, good. Any questions? Any comments from the peanut gallery in this class? We have no peanut gallery in this class. All right, we'll move on to fundamental thermocalculus part 1 then. All right, so what this one says is, so remember derivative and integrating, they're opposites, because integrating, you're taking the antiderivative. Derivative, you're taking the derivative. So if I were to say we're going to take the derivative of the integral from some number a to x of f of t dt, what the fundamental theorem of calculus part 1 says, that this is just equal to f of x. So this is how the author of the book writes it. So, and that's what I'm going with, but I'll explain with an example. It'll make more sense. This is an x there. Let me change the I want to change the notation here. 1 second. All right, so here we go. Suppose I said, let me give you an easier notation. So basically what this is saying is, if you're taking the derivative of an integral, it gets you back to the original function. So let's say g of x equaled the integral from some number 0 to x of the square root of t squared plus 4 dt. And I ask you to find g prime of x. So all you do is you would just say, so here's the answer. The answer would be, I'm going to do it in red. Don't blink, you're going to miss it. All you do is you take this x and you plug it in for t in here. So to see this x, you just shove it in here and you're done. That's it, done. Now, that's what the fundamental theorem calculus says. That's what essentially I said here. You take x, you plug it in here, and you get f of x, and you're done. Now, here are the questions that I had when I was a student. Does it not matter what the zero? What if the number 0 was a 1 or a 2 or a 3? Is it still the same answer? The answer is yes. Let me demonstrate by using an easier example. Suppose I ask you to take the derivative of the integral from 3 to x of t squared dt. So according to what I just said, the answer here should be x squared, and we're done. I'm saying is taking the derivative of the integral of t squared, the answer is just x squared. So that's using the fundamental theorem of calculus. Now let me explain to you, doing it the long way, the same exact problem, how that works. So if you remember, let's work from inside out. So let's just focus on this part right here, and then we'll take the derivative afterwards. So if I want to take the integral, so forget about the d over dx. That means take the derivative, but we'll do that later. If I integrate t squared, wouldn't that be 1/3 t to the third, and then from 3 to x? So then if I'm following the rule of the other fundamental theorem calculus, other parts, so that's 1/3 plug in x, so it would be x to the third, minus 1/3 plug in 3 to the third. So I plugged in x minus I plugged in 3. Now we got d over dx of 1/3 x cubed minus, this is 27 over 3, which is 9. All right, now let's take the derivative of that. Well, when I take the derivative of this, use the power rule, 3 times 1/3 is 1, x squared. The derivative of -9 is 0, so it's just x squared. So that's why it doesn't matter what number you plug in here. In this case, it was the 3, because this whole thing is a constant, and when you take the derivative of it, it's just going to go to 0 anyway. So you end up with x squared. So notice how I ended up with x squared here. But doing the shortcut, you just take x, you plug it in, substitute it in for t, and you're done. It all works out like that because you're taking the derivative of an antiderivative. So they cancel each other out, and they're just the original function with just new letters. Now, it does get more challenging because I'm just doing it to x, but let me have you do, now you guys do it the short way. Let me have you do one more here, then we'll kick it up a notch and do something more challenging. The integral from 5 to x, well, let's call this f of x, equals the integral from 5 to x of the natural log of 1 plus x squared, not x squared, 1 plus t squared dt. All right, you guys find f prime of x. This is a 5. All right, you should be take you longer to write the answer, write the problems than do it. So what is it? You just plug in x, right? So natural log of 1 plus x squared. How many of you got that? Good. Okay. Now we'll get to the tougher ones where you got to use the chain rule. Well, let's take a break. So we'll start at 4:06. Okay. All right, sorry you guys, I was a little late. I was on the phone, important phone call. Anyway, Brian, which part do you need to see right here? Or before this?
Yeah, it's okay. Or if it's possible, maybe at the end of the class, I could just take a quick picture of the first
Yeah,
part.
you can take a picture. Hold on, let me just show you the. Oh wow, there's so much here. Okay, go ahead, take a picture of this. Hold on one second. Let me. Yeah, go ahead, screenshot that. Say when you're done, I can move it.
Got it.
All right. Next page. Hold on. Wait. Okay, go ahead. But actually, hold on. Let me, because it's cutting out here. Okay, go ahead.
Got it. Got that one too. Okay. I know, and then we're good. Thank you, Professor. I appreciate it. Thank
Okay. All right. So moving on. So far I've done problems where it's some number to x. But what if it's something like h of x equaling some number to, like, let's say something other than x, like x squared. So here's how you do that. This is supposed to be an R, by the way. My R is weird here, lowercase r's. Okay, so here's what you do. I want to show you the formal way to do it, then you can kind of think of a shortcut as well. So let u equal x squared. So the problem was in black, so let me, the solution will be in blue. So we'd say, all right, let u equal x squared. So then du over dx is going to be 2x, right? Okay. So when you're taking the derivative, h prime of x is going to equal the derivative with respect to u. Let me explain this here, from 0 to u. We're doing a u substitution of the integral of 1 plus r to the third dr. I'll explain this in a second. So times du over dx. So what we did is a u substitution. So I said let u equal x squared right here, okay? So instead of x squared, we're going to put u. So if we're going to take the derivative of h of x, which is all of this. So h of x, we're taking the derivative of it, so we're calling it h prime of x. If I'm going to take the derivative, instead of taking the derivative with respect to x, I'm going to take the derivative with respect to u, then take the derivative of u with respect to x. So taking the derivative with respect to u, then take the derivative of u with respect to x. So it's the chain rule. So if I say h of x, this is equals something in terms of x, h prime of x is equal to the derivative of h with respect to u, then I'm going to take the derivative of u with respect to x. So you can think of it as, hey, the du's cancel out, so you are taking the derivative of h with respect to x, but they don't really cancel out. But you can think of that notation as, hey, if they cancel out, you wrote them in the right order. So let me write that up here if you're trying to find it. So if you have h of x equals something, and you want to take the derivative of h with respect to x, that's like taking the derivative of h with respect to u, then taking the derivative of u with respect to x. And you can see it works out when the du's cancel out, you get dh over dx, which matches the left side. So this part right here, you just shove u in here, just like all the other ones. So you get the square root of 1 plus u to the third And then you still have the times du over dx. What is u and what is du over dx? Well, that's what these guys are for. So you got one plus x squared to the third times du over dx, which is 2x. So this is square root of 1 plus x to the 6th. And you can put the 2x here or here, it doesn't matter. I put it on the left. Essentially, if you look at the final answer, it's just like you plugged in x squared in here, but then times the derivative of x squared, which is 2x. So if you look at the final answer, or here, you essentially at the very top took x squared and you plugged it in for r, but you also take the derivative of x squared. So let me show you, let's do one more, then I'll show you a shortcut. So let's say you got y equals the integral from 1 to cosine of x of 1 plus t squared to the 10th power dt. So write it out formally if you can. So let u equal cosine of x. So du over dx would be negative sine of x. So try to write this out formally, then I'll do it in a minute. So y is equal to, so y prime, if I want to say find y prime, is equal to, you want to take the derivative with respect to x? Well, take the derivative with respect to u first, right? I messed this up. My notes are in here. From 1 to u of 1 plus t squared dt times du over dx. So now this part would just be, hey, you just take the u and you plug it into there. What is u? Cosine squared x. What's du over dx? Negative sine of x. Oh, I forgot to the 10th power. I forgot to write the 10th power here. So it's 10th power, 10th power. Thank you for reminding me, everyone. How do you got this as the answer? So notice if you look at the big picture from the very top line, if you just plugged in cosine of x for t, it's essentially the same answer, but just you got to remember to take the derivative of cosine. That's the chain rule, which would be negative sine of x. Does that make sense? So if you have any number towards cosine or towards any function, that's how you do it. Now, let me give you a tip. Let me do another problem for you. What if you had some function, let's say x to some number 5 of f of t dt, so y equals. How would you do that? Well, just give you a tip. That's equivalent to y equals to negative 5 to x of f of t dt. So you can always flip an integral upside down, but it becomes the opposite. Here's the reason why. And then from there, you should be able to take it. Here's the reason why. Remember, when you're integrating from a to b, the integral from a to b of f of x dx equals capital F of b minus capital F of a. If you were to flip the subtraction around, you just get the opposite answer. So if you were to flip these two numbers around, it just becomes its opposite. So keep that in mind if you have a number like that. All right, how are we doing on this? Good? Okay, so that's basically what section 5.3 is. Trying to see if I'm forgetting anything. Well, let me have you guys do one, then we'll call it a day. This is a z. I put a dash through the z's. So h of x equals the integral from 1 to the square root of z squared over z to the 4th plus 1 dz. Find h prime of x using the fundamental theorem of calculus. Then Madison will share her screen and show us how it's done. Daniel, what does nani mean on the chat? N-A-N.
It's Japanese for what?
Oh, yeah, you know Japanese?
No, that's all I know.
Yeah, you know more Japanese. There's sayonara, which means goodbye. So the Vietnamese language is actually the official name script on how English, Spanish, script that they use is called Latin script. Is that the official name of it? So the Vietnamese writing is basically the same as English letters, but is that because I'm asking if was it invaded by a European country or in the past? I have no idea. Maybe French. Okay. So let's go here. So you that's basically how all North and South America, the four languages of North and South America is, let's see, you got English, Spanish, Portuguese, and French. So because all those four conquered North and South America. There's very little French left. It's just a part of Canada and part of Louisiana, that area. But even then, it's English here. And then you have maybe one little country in South America also speaks French. And then the rest is Spanish and Brazil, which is Portuguese. All right. So u equals square root of x, which is x to the 1/2. So du over dx is equal to 1/2 x to the negative 1/2. So you got the derivative is equal to, we're going to take the derivative with respect to u. So it's going to be 1 to u. And then we're going to take the derivative of u with respect to x. So this whole piece right here, you just plug in u in for z. So you got u squared over u to the 4th plus 1 times du over dx. Now substitute back what it is. U is square root of x. So square root of x squared over square root of x to the 4th power plus 1. What's du over dx? Well, it's 1 over 2x to the 1/2, right? Because I just rewrote it. So let's simplify this. This is going to give us x over x squared plus 1 times, you could have left it with a negative x1. It's fine. 1 over 2 times the square root of x, either or. How many of you got that? Or something close to it, equivalent to it? All right. All right. So that's 5-3. So look for the review sheet by tonight, or so you got the review sheet 5-3. I'll put on the review sheet what you need to focus on, basically up to this point. Make sure you understand the word problems. We'll talk about the word problems next class meeting as well. Their answers are to a lot of them are on there. Don't worry about the very last word problem with the one with the wire. That's like the last one I did for you. That's just the whole page. Make sure you know the other sections where you take the relative max, relative min, over which intervals is it increasing, which intervals is it decreasing, concavity, L'Hopital's rule. No, we did that last time, L'Hopital's rule. Did we? I'm trying to remember. Anyway, yeah, that's it. I'll stick around if you have any questions. Otherwise, I'll see you next week, Tuesday.
Professor, the exam is next Thursday, right?
Yeah, it's on the syllabus. Thursday, April 29th.
Got it. Thanks, Professor.
You're welcome. All right, bye.